Section 8.3 day 1, the laws of logarithms, will really show you guys the idea that I set out at first. A logarithm is very, very powerful in calculus. It's used in chemistry. But if somebody 2 weeks after learning logarithms was going to try to say, what is a logarithm? Often they're left kind of wondering, yeah, I don't know, what is a logarithm? It's just they're so kind of strange when you're doing just pure calculations with them, and you wonder what they are good for. You do have to be patient. You have to be in a further course, like a calculus course, to really see their true power. What I would again challenge you guys to do is anytime you're wondering what is a logarithm, put the graph in your head. Okay, and I'll simply draw it and then erase it right away. Put this in your head. It's the inverse of an exponential that looks like this, and it'll kind of remind you what is a logarithm in its truest sense. And why is that so important? Well, today you're going to look at again the laws of logarithms, and it's very much a case of, okay, great, I understand what you're saying, but I don't get it. Like, where could you possibly use this? You just got to go with it. Remember, the entire course and Pre-Calc 20 are just learning tools. You're learning tools so you can use these in a later course. Now, what we look at are three very important laws of logarithms, and don't let the initial formulas scare you, and even if it says in the PDF notes, memorize this. What it's doing is it's showing you that if you have logarithms in a certain arrangement, a multiplication, a division, then a power, you can actually rewrite them. A multiplication can be busted apart into an addition, a subtraction can be used in a division, and you can always take a power down. I often star this one and say it's the most important one. Now, what does that really mean? Just watch this little example that's not even in the PDF notes. Let's say you were asked to calculate what is log, and then you had a 4, and then you had to multiply by 9. Now, let's just review this. This is kind of an old school one. Here is one way you could solve it. You could just say, well, this is log 236, and you could do that old trick where you let it equal x and you spin it around. So 2 to the power x equals 36, and then you could make your calculation. But what if you were saying, well, I don't like that, I would need a calculator, how do you even solve that? There's another way you could do it. Okay, and we're not going to look at the numerical answer. What they've figured out, they meaning mathematicians a long time ago, is you could actually break up this multiplication and you could solve it separately. And it might just be a little bit easier. There might be a reason to do this where you could just go log 2 4 and then add log 2 9, and it will be the exact same as what this originally was. And it does have its purpose, even though this little example doesn't fully show the purpose because we're not even going to finish it. So what would today look like for a bit of practice? What you're going to start with is just some very theoretical questions where there's no grand finale. It's just kind of practicing the laws to memorize them. And it's very simple. Okay. For number 2, it says just expand it into individual logarithms. And don't worry, it's not like you have to be left wondering, what does this mean? When does this happen? It's pretty obvious. So the very first one says take log base of 7, that's the subscript, and then an x divided by y. And all you're trying to say is you could bust this apart into log x with the 7, and then log 7, and then with the y, and have a subtract. That's it. Okay, we're just trying to memorize the law, and there are reasons why you'd want to do it. The next guy just again goes purely algebraic. Log and the basis time is 4. That doesn't really matter that much. And if x, y, and z are all multiplied together, all in the name of just trying to memorize these laws, you could bust it apart and you could do a series of additions, each separately. We're trying to memorize these rules because at some point they will become important. Now, letter C just takes us back to some of the old days. It's all in the rewrite. Let's say you had this and you wanted to just rewrite it to memorize the laws because at a later point it will become important. Here's what you could start with. You could say this is log 3, and then a square root means a power of a half. And what you can do always with a power is you can bring it down in front and make it a whole number. And whatever you're doing later, it will come out the same. And then our final one in this little run of, let's just get to know them. We have a log 5, and then we have an x to the power 4, a y squared divided by a square root z. So here's how you could begin. We'll just do it in 2 quick steps. What you could say is, this is technically log 5 x to the 4th plus log 5 y to the power 2, subtract, because it's a division. And then we have a log 5z, and I'm going to change it to a half, just like the previous question. And then for a grand finale, you can take all the powers down. You can have a 4 in front, and it doesn't change the ultimate value. If we were doing something actually useful, we could put a 2 in front, and we could put the half in front. And we're again just memorizing these laws. We're not trying to do anything dramatic. Now, number 3, the end of the day, is where you actually do something which isn't maybe I see it. You're not going to see what the ultimate purpose of logarithms is, but it'll feel a little bit better than number 2. So let's say we had to do the old evaluate. No more variables. We're just going to use numerical values. And what we're going to do is we're going to spit out, what would this equal? Let's say you had a calculator that was powerful enough to type this in. What would be the answer in the very end? Well, here's what we're going to do. If you just look at it separately, you might be wondering, I don't know what to do. What would I do? So in here, what we're going to do is we're going to apply the laws. We will look at this and say, okay, the base is 6. The base always has to be the same, and it is. An add can be brought together into a multiply. You can write the 8 and the 9 multiplied together, and a subtract, as long as the base is the same, can be brought together to be a division. So here's what really is unfolding. We have 72 divided by, 72 divided by, and I made a misprint, I was looking at the base, 72 divided by 2 is 36. Now, I'm just going to do this one backwards because I already have the equals sign. We're trying to say, what is this equal to? I'm going to do the old trick where we say equal x, spin it around and rewrite it exponentially, and then suddenly you see, oh, it's 2. So here's where the laws come in handy. If you had a calculator that was powerful enough to type this in, and you had equals, you'd see a 2. Let's say you had no calculator. You were stranded on a deserted island. How the heck would you do this? Because this little spin around would not work so good. 6 to what power is 8? This is where the laws start to at least show a hint of what they're good for. So for our second example, we have log with a base of 5, 1,000 minus log, base 5, a 4, and then another minus, and a log, and a base of 5, and a 2. You'll start to feel a little bit more comfortable, and there's something that you need to see out of the logarithm setup. So first of all, we have a log and a base of 5, and a subtract means we can do a division. We can put the 4 here. This subtract also means it parks like a division, and don't get confused, related back to the original term, all it simply does is it parks the 2 beside the 4. Just think this guy is on top, the minus puts both of them in the denominator division. This is then log 5, and 1,000 divided by 8 is 125. Then we can start to do our spin around. 5 to the power of x is equal to 125, and we see that x is 3, and we've evaluated this logarithmic expression. So it does again feel a little bit better than number 2 in the notes, but you're still kind of thinking, well, where would I use this? You got to be patient. It's in chemistry and calculus mainly. So your final example goes a little bit larger. It says evaluate, get a numerical value for 2, log 2, 12, and then a subtract, a bracket. We got to still follow our old rules of order of operations. All right, so here's how I'm going to begin. I'll just do a couple of things at once. I'm going to take this 2 and bring it up. Yes, you can do that. You can bring a power down. You can bring it up, whatever suits your needs. You'll be wondering the first time, kind of like chapter 6, how am I supposed to know to do that? Just with experience, you would know. We're trying to crunch this together to be just one term, while by bringing the 2 up and then eventually saying this is 144 will serve us well. Inside this bracket, we have log 2, 6, and then what I'm going to do is bring this 1/3 up, and we have a log 2, 27 to the power 1/3. We got to do a little bit of evaluating. I'll just tidy the first one up to a 144, a minus, I'm thinking division. Now in here, this is going to go quicker than you think. The 1/3 power means cube root. The cube root of 27 is a 3. So really what we have is a log 2, 6 plus a log 2, 3. The plus means we can multiply to a log 2, 18. Now finally, base is the same. I can do a division, and this comes out quite nice. 144 divided by 18 is a nice clean 8. We're supposed to evaluate this by using the laws. We can get back into the old trick of letting it equal x, doing the spin around, 2 to the power x equals 8. And we see that this evaluates to a nice clean value of 3. So just to finish off, I want to remind you guys, don't panic. We're just trying to get comfortable with logarithms, do some of the calculations. The real purpose behind these will have to wait for a further course. And anytime you're in doubt, always again, remember, what does the graph of a logarithm look like? Go to that. Okay, it's just, it doesn't save the day. It doesn't help you with these calculations, but I think it really kind of calms you down when you're kind of wondering, well, what the heck is a logarithm and what is it good for? Always go to the graph.